Because of this problem of affirming the consequent and the need to test our hypotheses using observable predictions of consequence from the antecedent of our hypothesis, at the very heart of science lies something called the principle of falsifiability. It was first stated clearly by an American philosopher by the name of Karl Popper. And he argued that in order to be considered scientific, any hypothesis must be falsifiable. You must, in theory, be able to disprove it. What that means is that you have to be able to use deductive reasoning to make predictions that can be observed so that we can either deny them or affirm them. Now remember, why is this the principle of falsifiability? Because the only thing, remember, that we can validly do logically is to deny the consequent. So in other words, we're trying to disprove the hypothesis. And if we can't disprove it many, many times, then we have reason to believe that, well, maybe it's actually true. So scientists spend a lot of time actually trying to figure out what are observable predictions that come out of my hypothesis that we can then look for in order to try to falsify the hypothesis. So let me show you a short little video clip on a couple of scientists working on developing those things to look for, those observable predictions coming out of their hypothesis.
All right, we're going to be designing an experiment to look for the annihilation spectrum resulting from dark matter collisions in space.
Ooh, dark matter. We better bring a flashlight. I was making a joke.
I'm the boss. I make the jokes.
Sorry, go ahead and make your joke.
This is not the time for joking. We're doing serious research which requires complete and utter focus.
All right, let's buckle down and work. Sheldon?
What?
I need an aspirin.
Top desk drawer. Thank you. All right? Yes, good.
So the bottom line here then is that because of our recognition of the limits, the fallacious nature of denying the consequent or affirming the consequent, which is the only thing we can do, scientists actually try to prove themselves wrong. And if they repeatedly fail to prove themselves wrong, then they have a logical reason for believing they're actually right. And now we get to the difference between a hypothesis and a theory. Because once you've tested a hypothesis abductively enough times to believe that it's actually true and to convince other experts in the field that there's sufficient reason for thinking that the hypothesis actually is likely to be correspondingly true, then it becomes a theory. Okay? So the difference between a theory and a hypothesis is that a theory has been well tested using empiricism, inductive reasoning, and deductive reasoning. So if you ever hear somebody say, well, I don't believe this because it's just a theory, they don't understand what a scientific theory is. To say, I don't believe it because it's just a theory is to say, I don't believe it because it's just been very thoroughly tested using rationalism and empiricism many, many, many times, which makes no sense. When people say that, they are betraying their own ignorance of the scientific method rather than anything about the actual certainty of the idea. So a hypothesis is an idea that when plugged into deductive arguments actually gives us the consequence that we can observe. A theory is one that has actually been plugged into many deductive arguments and has been shown to give us the consequence that we observe. So a theory is kind of a grown-up hypothesis. But of course, the testing never ends because we're always observing more and more about the universe. And we're always collecting more consequence that need to fit with that antecedent. We saw did we see examples of this? I don't know if we saw examples of this. But scientific theories are therefore always tentative. Tentative means for now. We always keep in mind that no matter how well tested a theory is, some future observation may actually contradict the predictions of that theory, and then we will have to modify or possibly even reject a theory that we had believed for a very, very, very long time.